Lesson 8.6, Linear Programming. Linear programming is an optimization strategy, which means you can use it to find the maximum or the minimum of some function. It has several parts. We have an objective function that you want to optimize, find the maximum or the minimum of it. And it has some constraints, which are a system of inequalities that limit different the values of the variables. First step is to graph the constraints and find the vertices of the solution. Turns out the maximum or the minimum will be at one of the vertices, or possibly any point on one of the edges between the vertices, but that would be all the same value. It won't get higher or lower along an edge. The highest and the lowest will be at a vertex. So the graph should look like this one. And then, after you know your vertices, you plug the vertices into the objective function and just see which one gives you the minimum or the maximum. So let's use linear programming to find the minimum value of function z, given these constraints. So the inequalities are the constraints, and z is the objective function. So we start by just graphing the constraints. So x is greater than 0 or equal to, so that means it is solid line. X equals 0 is a vertical solid line. And we want to be greater than 0, so it'll be where the x's are bigger. The second one, y is greater than or equal to 0, so that's a horizontal line. And we're shading above that because it's y is greater than. This third one, if I solve it for y, it'll be y is greater than or equal to negative x plus 2. So let's start at 2. And we're going to go down 1 over 1. And it's solid. And we're shading above. And then the fourth one, y is less than or equal to 4. So that'll be a horizontal line where y is 4. And it's less than that, so we're shading below. And then the last one, x is less than or equal to 5. So that's a vertical line where x is 5. And it's less than that, smaller x's. So the area that is all shaded is this little trapezoid, sort of. It's not a trapezoid, it's a pentagon. But we need to know the vertices. So that one is 0, 4. One below it is 0, 2. This one down here is 2, 0. That one is 5, 0. And this one is 5, 4. What we need to do now is plug in each of those into the objective function. So let's start with 5, 4. So z would be 4 times x, which was 5, plus 6 times y, which was 4. And that gives you 44. Let's try another point. How about 5, 0? So it's 4 times 5, plus 6 times 0 is 20. Well, that's smaller. How about 2, 0? 4 times 2 plus 6 times 0 is 8. Well, that's even smaller. Let's try 0, 2. Remember, we only do the vertices of the shaded area. Looks like we get 12. The last one is 0, 4. Fill in a 0 and a 4, and we get 24. So we want the minimum. The minimum is 8. So the minimum is 8, and it occurs at 2, 0. So this linear programming is occasionally actually used in real life to maximize or minimize costs or profits or work on efficiency or things like that.